Yo, oh, what's up? It's your boy. This does.
Okay. Hello? Did Davey tell y'all how he fixed it? No? No? Okay. Alright. Oh no, what did I do? Oh my god. Oh, you know what? I probably actually know. Hello? No, actually I don't know. Whatever. Uh, screen space. Sup? Oh, I'm a ghost. I'm a ghost in Calgary because the camera's frozen. So, it's just a mess. It's okay. Today's lecture is going to be short. Okay. Right. Oh my god, today's Friday, isn't it? Yo, that's good news. Hey, how many of y'all have like Friday night plans? Right? Are any of y'all looking for something fun to do tonight? It's Friday, yeah. All right, Connor, can you see me now? Let me know if I'm visible. Yes, sir. Awesome. Sup? All right, so today we're gonna do something. I'm gonna preface this, by the way, by saying that I wasn't your original lecturer. Sam's sick. So in case this is the worst lecture you've ever seen, um, can I just pin it on that? Is that a thing I'm allowed to do? Yes. Yeah. Yeah. I think that is the way it should work. I have some little notes to Reno here, and I just need a second to get that stuff open up on my little notes. Also, Calgary, I'm gonna try to sniffle as little as possible. I took a bike ride here. Y'all know about bikes? They exist. I haven't gone biking in a long time because I have. You know how some people have like baggage, like emotional baggage? I have no. I'm like genuinely serious. I have like bike baggage, because I used to be really into cycling, like road cycling. I got I got a bike as oh there we go, found all the notes. I got this bike as a present once, and I got like super into cycling, and I was I was a hefty boy. Like I had a little bit of yeah, there we go. I had a little bit of extra. I still have a little bit of padding in like my ankles, places where people are insecure and all that. But I got like super into cycling, and I put my eyes on this thing. The let's open up the Google Chrome. I got my eyes on this thing, the Grand Fondo. Oh, looks like Nima's not even connected to the Wi-Fi. What the hell? So the Grand Fondo is like this ride from Stanley Park to um like Whistler. It's a good ride. They like close off the entire highway and you can just bike. And that was my dream. I'm like, I'm gonna do it. I'm gonna do North America's largest Grand Fondo, the RBC Grand Fondo to Whistler. I trained. I trained from like February out until September, and I was biking like 5, 6 times a week. I ate so much oatmeal. I had bananas. I got into like the best shape of my life. I lost like a good 30 pounds. I was this lean biking machine. And then I make it to Alice Lake, just past Brackendale. It's the last stop. It's the last stop before the final stretch to Whistler, and my goddamn rear derailleur snaps off. Okay, it just snaps like clean off. Oh my god, I was so upset because I'd had so much trouble with my bike in the previous like weeks. Best ride of my life, and then it snaps off, and I sunk into what I can generally describe as like probably the deepest, darkest hole I've ever like slipped into for like months, years even, because this was 2 years ago, and I'm still feeling the repercussions. Anyways, I got on a bike today, and I hadn't biked in a long time, and I feel really good. So, that's my success story. I'm Nima, and I'm here to tell you that you too can make it through. Um, it's yeah, I don't know, man. It was hard. It was really hard. So today we're gonna learn about these things called prototypes. Let me make a little notes MD prototypes notes MD. Look at that. There's no info here. Awesome. All right. It is week 6, day 5. It's Friday. How you liking React? How's that going? Any major qualms? Any fist shaking? React? No? Are you liking it? Like, actually? Can you see yourself maybe, like, dedicating a good portion of your career to it? Some people do, right? I did. I do. Right. How do you like WebSockets? Not as much. Ooh. What is it about WebSockets that's been a pain for you? I'm also gonna get Calgary up here so I can watch. What is it about WebSockets that frustrates you particularly? Hmm? Oh yeah. Looking at the code. Oh, Connor's typing. Connor's gonna say that they love. Oh, actually like WebSockets. Found them easy to pick up. Awesome. I'm glad to hear it. WebSockets, incredibly useful, very powerful. What you might not like, and I totally don't disagree with you here, is the WS module. A little bit trash, right? A little bit hot dumpster fire. It's like I'm not a fan of the WS module. What I like is this thing called socket.io. Hey, Socket.io, featuring the fastest and most reliable real-time engine. It's just another kind of abstraction layer on top of sockets, but it's got all sorts of little built-in things like, when you have to send different kinds of messages, it's a pain. Like you have to wrap messages with like a type or something. I know like a lot of people tend to get confused about that. With Socket.io, you can io.emit. This would be socket.send for you. And then instead of just passing a string, you can pass a type and an object. So Socket.io just allows you to do all that stuff. You can send objects back and forth. You can give your messages types, so you can listen for particular types of messages, right? It's like the next step from how we went to like Express, and that was that awesome layer of abstraction. Socket.io is like that layer of abstraction for WebSockets. So if you think about like wanting to use WebSockets for your final project, take a look at Socket.io. You can do all kinds of things like set up rooms, so you can put people into groups, and that'll be easier to deal with than if you were trying to do that with the WS module. Giving types, you can send full-on objects, all sorts of stuff. It's a really, really great library. But the setup, it's a bit different than the WS module. It's not that it's not easy. It's just it's different. So if you need help with it, just let me know. But I am gonna put that in here in the notes. Take a look at socket.io. Pretty cool. Okay. That being said, today's Friday. We're gonna be looking at prototypes. Now, I am going to preface this by saying that I think the concepts that we're going to look at, right, they're going to be interesting, but they're sort of inconsequential as, like, compared to some of the other things that you learn. Like, you learn callbacks, and I'm like, you gotta understand callbacks. You gotta understand. Right? You learn other stuff. I'm like, okay, you gotta learn that stuff. Prototypes, this is more like a peek into what's going on underneath in JavaScript. It might be a good opportunity to clear up some misunderstandings or some just kind of nebulousness that you might have had before. And what today's entire lecture kind of hinges on is objects. Right? What are objects? Right? Where do they come from? Where do they go? Where did they come from? I'm not gonna do this full song, but like that's objects for us. This is what we're gonna look at. What is an object? Can anybody tell me what an object is? Yeah, sure. I guess an array is an object, but yeah, a grouping of key value pairs, right? At its most pairs. A grouping of key value pairs at its most basic. How do we make objects? Can somebody walk me through the keystrokes that I have to go through to make an object? I mean, you should know this. Huh? In JavaScript, yeah. All right. I could toss in the keys. Could I even just stop here? Yeah, I made myself a nice little object. Right, little curly braces. Right, fairly simple. Fairly simple, and one would think, what do we call this? This kind of object? It's an empty object, right? All right, let me hop into Chrome. About blank. Pop up the little console here. Zoop. Okay. Curly brace. Curly brace. Enter. All right. And now I see something that's kind of teasing me. It's like, ooh, like open. Because the thing is, we've been socialized, right? From a very young age. Well, maybe not a young age. UI kind of tells us that I should click on this. And what should I see when I click on this right now? Huh? Wow, way to hop way ahead of me. Yeah. I open this up and I'm expecting this to be an empty object. What? Oh, proto. Oh my god. Oh, let's hide that. What is that? So today's lecture is going to repeatedly just kind of get closer and closer to this and back away from it until we're ready to like hop in head first. Right? Proto. Wait, this was the cohort when I went like nunny, right? Is that So I told my friend I'm gonna do like an entire. I don't even actually watch anime. Is the thing. I've seen One Punch Man. That's it. No, I've seen Samurai Champloo. That's really good. And I've seen Your Name. That's a good one. Okay, so I've seen maybe more anime than your regular like middle-aged white man. Maybe if we were to like median person, I guess I've seen more. But so proto, and we're gonna explore this. But this is an empty object for all intents and purposes. I didn't write anything here. Now, there's a couple different ways for us to create objects. Right? This is one way. There's another way. This is called an object literal. There's another way, and it has to do with a word called new. Now, I don't think, have used new very much other than recently. What did you use new with? Constructing an instance of a class, or constructing an instance of like the WebSocket connection that you're using for chatty. Right? So you might do something like new WebSocket. Okay. What is the difference between that and this? It's a very subtle difference. Yeah, it's not going to give you an instance of WebSocket, but the capitalization. So this here, if it wasn't for the word new, it just looks like a function call. Right? Looks like a function call. It's just weird because like we don't usually write our functions with capital letters. Now we've put the word new in front of it. This is what we call a function constructor. So what we're getting into today is looking at how JavaScript kind of represents values underneath, and how it chains objects together. It's like hierarchy of things. JavaScript is not what we call a truly object-oriented language. Right? It has objects, but it's not what people call object-oriented. It's based on these things called prototypes. And now, anything that we create, I'm going to annoyingly pop open and go, whoa, there's the proto, right? And then probably towards the end of this first half or in the beginning of the second half, we're going to explore exactly what that means. For right now, I'm going to go ahead into my script here and scroll way up. And I've got some examples. So this here, here's a literal object that I'm making, right? Literal object that says key colon value. Here's another thing that I'm making, num equals 2. I mean, we call these literals because we're writing out the literal like representation of the object. This here is a function constructor, and there's something really funky about it. Right? It's a function, but the first thing to notice is, again, it's written with caps. And the second is that on the inside we write this. So I'm going to start without even having this in there, and we're just going to start with function cat. So function cat. If I run cat on its own like this, nothing happens. Right? Cat is a function. Cat is a function, but if I run it on its own, nothing happens. If I go new cat, all of a sudden something interesting happens. I get back not just an object, but an object of the cat type. In fact, I even see it written out here. It goes cat. And if I was to pop this open, there's nothing in here. There's nothing in here, and we're going to be exploring proto. But if I look into proto, I see proto constructor is cat. All right, so we're going to tinker with this stuff until it starts really making sense. But basically, so far, new cat has created a new cat object, which, again, for all intents and purposes, if I was to save this in cat1, now we'll do a cat name, Felix. Right? Felix is what? Feliz. Felix is now some object, and I can do things like felix.ears equals pointy, maybe. And if I check in Felix, it's a cat with ears that are pointy. But what I really want you to see from this is that I'm treating this like an object because it is an object. Right? It's a JavaScript object. And again, in the constructor function, I hadn't written anything. I'm going to go ahead and get weird now. I'm going to go, let's go edit that constructor function. And I'm going to make this one be mood jerk. Cats are jerks. I like cats, but they scare me. I've never met a cat that liked me. So, cat. And I'm going to run that code from before again. Let's go Felix equals new cat. Then I'm going to pop open Felix here. Whoop. I don't see anything. I'm going to open up proto. Wait, what? Where'd you go? That wasn't supposed to happen. Oh. How did nobody stop me on whatever the hell this is? This is not real syntax. Let me fix that up. This is supposed to be this.mood equals jerk. Sorry. So just reiterating back on this. Cat, I've just written the line this.mood. Right? I'm going to explain what this does in a second, but I'm just going to write this.mood equals jerk. Run the code. Felix equals new cat. And this is what I wanted to show you, was Felix now, when I've made Felix, has the mood jerk. I'm going to make another cat. Let cat equals new cat. And if I look at cat, cat also has mood jerk. Awesome. Right? Maybe I want to make a lot of objects that should have the same kind of starting properties. I can use a function constructor to essentially create a blueprint for an object. Right? That's the whole idea behind these function constructors is I might want to start off with like, okay, every cat has to have a mood jerk, and then I go this dot fur soft, and this dot meow meow, right? Just some blueprint for a cat. And now every time I make a cat, it's made with all those things that I said a cat should have. Now, let's take a quick thought about what you're doing with the WebSocket connection, just to tie this to actual programming stuff. You write something like new WebSocket, WebSocket, and I point it to like Mark Zuck's fridge or something, right? Yeah, there we go. Mark Zucko's fridge. Here's a new WebSocket, and I want you to see that this is exactly the same as new cat, like exact same thing. And what happens is when this gets made, what I get back is an object of the WebSocket type as opposed to an object of the cat type that has a bunch of things already set up for me, right? So function constructors are going to be useful for when I need to create stuff of a particular type with some structure and often some parameters. So for example, I might want to give my cat a name. You might have noticed that like when I do WebSocket, I can pass in parameters, right? I can do that with changing cat here to maybe take a name. And now I'll say, okay, well, this dot name equals name. And now anytime I make a cat, I can go, oh, okay, well, new cat with the name Meowstifer. There you go. And now I've got a cat that has mood jerk, right? Meow, meow, fur, soft, and name Meowstifer. Right? I've created a new cat of the cat type that has all that stuff. That way I don't have to keep rewriting that stuff, right? It's just encapsulated in one function. And it's also become custom to some parameter that I've given it. Now, I want to talk about this. Inside of the constructor function, this is a reference to the object that you're creating. Right? Can I make it as simple as that? Can we agree on that? This is going to be a reference to the object that you are creating. So this essentially says, okay, that new object's mood is jerk. That new object's fur is soft. This means that I can have multiple objects created. Let me go Meowstifer is, new cat Meowstifer here. And I can do another cat. Anybody have a cat? I do actually like cats. Paige? Peach. Peach. Like the nice. New cat Peach. Oh no, I wrote peak. Well, if I check into Meowstifer here, right? Meowstifer has fur, soft, meow, meow, mood, jerk, and name Meowstifer. Right? If I look into Peach, peak, this is different. So again, this is a reference to that new object that you're creating, and that new object that you're creating is a unique instance. Right? I'm going to call it an instance of a thing. So this is going to, again, allow us to create unique things. So for the WebSocket connections, in your chatty, you currently only have one WebSocket connection. Right? But just imagine, you could have a million. They could all be unique WebSocket connections, right, with their own unique parameters, all saved into variables. Now, we can get as funky as we want with this stuff. Whoa. You can't see it, but my screen is flashing right now. It's kind of nuts. Wait, I'm gonna blow my nose real quick because Calgary is getting a bad deal. Whoop. Okay. So going back to some of the code that I've written before here, I can have multiple function constructors. I've got this one that says function cat that returns a cat type thing with this dot pause and this dot color. And I was going something like const Garfield equals new cat. Now, interesting, if I'd made my function constructor here lowercase. Oh, okay. Well, this is because I already have an identifier called cat. Let me do cat construct. I don't actually know what would happen if I would go new cat construct. So you can test it out. Bradley. Cool. It works. I had no idea. I just wanted to test it out. By convention, we make our function constructors uppercase for the first letter. Right? So just do that. It's kind of like how in React, your component names should be uppercase to start off with. Right? Have you noticed that? Actually, in React, I think if you do a lowercase letter, like it doesn't even let you use it, does it? I think when I've done it, either the linting goes off or like it just screams at me. So we've got these function constructors. Here's another one for dog that takes a parameter. Now, there's also such thing as object create for creating objects. So, oh no, system preferences. Object create. So there is this global thing called object that you have access to. You might have seen things like object keys, for example. Right? And this is a reference to the global object and the keys method that lives inside of it. Right? So if I went object keys and passed it an object, this returns an array of all the keys. So similarly, there's an object create in here. An object create receives what we call a prototype. And this is how it's going to behave. Here, I have an object literal that I've made called gecko. And it goes type, lizard, legs, 4, tail, true, savings, 20%. Right? I've got gecko. And if I then go let gecko equal, not gecko, but object.create gecko, something funky happens. So here's my gecko. Then I say something like let gecko equals object.create gecko. I've got my gecko. What? What is that? What? It's an empty object. Or is it? So I know a gecko should have a type. Oh my god. But like gecko has no keys. Right? Where could this stuff be? Where could gecko.legs be? It's in the proto. Right? So when we do something like object.create, right, this is functionally a little bit different than what I was doing with the function constructor, right? Where it's hiding all those values. It's hiding all those values up inside of the proto. Right? So unlike the cat, where those values are available right at the top, and I actually even see the type of the thing, like, where is it, cat? If I was to do something like object create, it's just hidden in the proto. If I was to go ahead and make another gecko2, and I go gecko2.legs, I'm seeing that there as well. If I went gecko2.legs equals 5, oh, whoops, I wrote gecko.legs, didn't I? Yeah. All right, so I went gecko.legs. So I edited my gecko. If I went gecko, I now have legs as 5 here. I pop this open. I see legs 5 here, and I pop this open. I see legs 4 in the proto. What? So there's that like chain of inheritance. Or basically like I can edit Geico to give it a particular number of legs and still leave that proto as it was. If I delete the Geico legs, I look at my Geico, there's no legs in here, but the proto's still there. And if I Geico.legs, I'm back to 4. This is where, again, I really want to stress that the stuff that I'm showing you today for lecture, right, is going to be useful for the assignments, right, to some degree, as in like you have a couple assignments on this stuff today. But beyond that, I don't want you to stress on this for the boot camp, right? This is something that, like, depending on the job that you get, you might have to, like, learn a little bit, right? But it's very, very specific to one corner of JavaScript. Okay, so what a prototype is it's a thing that lives inside underscore underscore proto for an object that object can pull from. So I really want us to see that Geico inside of it immediately does not have legs. But when I go Geico.legs, JavaScript's going to look. Do I see any legs? No. Okay, I'm going to hop my way up into its proto and check to see if there are legs there. What you might notice about this proto is that there's another proto inside of it. A proto pointing to object. And I could open this up and see that, oh, here are a bunch of things that have to do with objects. So here's like an array. Let array equals 1, 2, 3. If I check inside of the array, I'll also notice that there's a proto. And it'll tell me, oh, okay, an array is an array type thing. And if I keep working my way down here, I'm pretty sure there's another proto. This is what people mean when they say, like, everything in JavaScript is an object. Because you work your way up the values, protos, and eventually you're going to find object in there. Right? So here, an array, we've seen, we can go all the way up and find out that, oh, it's just an object. It's just an object with these methods added to it, right? And a length and values. Same with a function. If I have a function, some empty function, and I check to see what that function is, sa.proto takes me to function, and .proto again takes me to whatever this is. And I can keep working my way down. Can I? I haven't actually done this before. Oh, there we go. Actually, yeah. Constructor, object. Right. So the second proto for a function takes you to an object. So JavaScript at its core is whatever this object is, defined as this thing that we call, again, a prototype, which is a blueprint for other objects that want to be of that type. And anytime somebody uses that blueprint, they can tack other stuff onto it. Does this idea, like, I know it's a bit weird, but is it making a bit of sense? And this is very specific to how JavaScript does things, right? Other languages might work differently. So, underscore underscore proto is the prototype property. Ignore whatever in here. We're going to explore that a little bit more. So, here are two examples of me using a function constructor that we've seen already, and then me using this class syntax. Class with the constructor in it. Same thing. They are the same thing, right? You might have wondered why in React you can do class component, with like the constructor or whatever, or you can do const component as like a thing. Like this is okay, they're not identical to what I'm doing right now, but this is like syntactic sugar for making a simpler version of this. And in our case here, the class syntax for making an object is syntactic sugar for the function constructor syntax, essentially. And, I want to run this code here. So if I go, okay, here's function cat fc, and here's cat class. That again, inside of here, they both go this.pause 4 and this.color orange, except in the class I've wrapped it in the constructor. Now if I was to make a new cat class object like Garfield, I can check inside of Garfield and see Garfield is a cat class type with pause and color. And Heathcliff here is a cat FC type with color and pause as well. Right? If we were to hop into the proto, our constructors just look different. This one's got a class constructor and this one's got a function constructor. But functionally, we see on the inside, they're the exact same thing. You can choose whichever one you want, right? You could make classes or you can make function constructors. Yes. Well, so the advantage would be this, like classes are things that exist in other languages. So somebody moving into JavaScript can like be really familiar with this, especially if you want to start adding methods to this thing. So maybe every cat should be able to meow. Right? Now I've added this to the cat class. Let me just refresh because, okay. I've added that to the cat class, and anytime I make a new cat class object, Garfield is able to meow. Right? And it's just nice syntax for me to, in the same way that I add a constructor to my cat class, add more methods. Interesting, if I was to like explore where this is, so Garfield, I don't actually see it in here. It's inside of the proto, right? Whereas for this here, my cat function constructor, if I wanted to add a method to it, I might do something like this. Right? Where I've attached this function as a property underneath cat function constructor. But there's a slight difference. If this is my cat function constructor and I make a cat like Heathcliff, and I check inside of Heathcliff, I can meow. That's fine. But if I look at Heathcliff, the meow actually lives underneath the main stuff as opposed to inside of the proto. Because I've said in the function constructor that this meow lives underneath the object. So that's one of the advantages, is that I can keep meow at the level of the prototype. Advantages to this are that right now, every time I make a new cat with a function constructor here, every cat is going to have its own function created, which might be wasteful, right? Maybe I don't want all of these functions created. Like, it could just point to one place, right? Other advantage, like as opposed to having so many of these created all over the place, is also that if I have my proto pointing to one place, right, I can go to that one place and edit it. So something that I haven't really talked about so far is that as you're creating these objects, right? So if I was to make a bunch of Garfields, right? So this is Garfield with the new cat class, and I went, let's make a Garfield 1, and Garfield 2, and Garfield 3. All of them so far, whether they're Garfield 1, 2, or 3, they meow. And what I can do is go into like Garfield dot proto dot meow. I'm pretty sure. I might mess this up, but I have a demo to do it properly and actually change how the meow goes. And now let me see if this works. If I go Garfield.meow. Oh, whoops, I forgot to write console log. Yeah, good call. I'm thinking Ruby mode right now. Ruby you're going to find out next week. Yeah. So, if I Garfield meow, Garfield moos, and if I Garfield 1 meow, Garfield 1 also moos. Right? But interestingly, like I went into Garfield.proto. I didn't go into Garfield 1.proto. But since Garfield, Garfield 1, Garfield 2, and Garfield 3 all share the same prototype, I can go edit that one prototype and everybody gets the change from that. And there's usefulness in that like I can augment or change a bunch of objects that already exist by going to one place. Yes. That's a great question. Let's see. So I hadn't thought about that. So here's my Garfield, and I go JSON.stringify. Oh, so the question for Calgary was, what happens when you convert one of these to JSON? Does it get rid of the proto? And I don't know. Looks like it does. Wow. So I guess when you JSON stringify, it just takes the top level stuff. So maybe that's something to think about then. There might be something you can do to stringify with proto. Let's see. If I was to convert this, no, it wouldn't be able to. Like you're saying, if I parse this here, no, it wouldn't remember, because when it parses, all it parses is. All it parses is what it sees in the string. So this just becomes an object literal with color orange pos 4, and its prototype is object. Right? That's a really good question. There might be something. Yeah, JSON stringify does not preserve any of the not owned properties. What they mean by not owned here is that technically the prototype stuff is not owned by the object that you're dealing with, right? It's not owned by it. Instead, I'm just pointing to somewhere else, right? So over here for Garfield, for example, my Garfield object does not own meow. Garfield does not have meow. What Garfield does have is a proto. So if I ask Garfield to meow, JavaScript is going to look into Garfield, not see anything, and it's going to hop into the proto. Now, we saw that with a function constructor, I could give methods by writing this, but it ended up being at the top level. We can get around this in slightly ugly kind of syntax. catfc.prototype.meow. Right, so now this here, what I've written does what this class does. So I have access from the function constructor to a method called .prototype, not a method, to a property called .prototype, where I can set things like meow. So here's, let me just do that again over here. Now if I was to make a new cat like Heathcliff, I look into Heathcliff, I don't see Meow, because Meow is actually saved in the prototype. So there's this weird kind of relationship between underscore underscore proto and dot prototype. Underscore underscore proto, like you can use that from an object to work your way up to see who am I inheriting from, right? So this underscore underscore proto, you can go into that Heathcliff dot underscore underscore proto underscore underscore. I can work my way up and say who am I inheriting from, and that'll return back an object that was used as my prototype. On the opposite end, I can use from the function constructor, I can go dot prototype to see the prototype that would be created. So if I want to add things to that prototype, I can go catfc.prototype dot and add things to it. And that's stuff that won't be saved at the object level. It'll be saved in that object prototype. Right? And this is really the kind of thing that you just have to play around with and fiddle around with until it makes sense, right? So I've put in the notes some examples for you to play with, right? But again, like you won't get it until you get some time to tinker. Now, this whole dot prototype is neat because I know that there's a thing to make arrays. I can make an array literal. I can go let array 1 equals 1, 2, 3. But there's also new array that makes new arrays. So some function constructor for that. I could look at the array.prototype. See the hidden secrets of arrays. Look at that. Array.filters in there. Array find. Array includes. Array push, shift, slice. All these things. So what if I went array.prototype? I haven't actually tried this before. I just thought of it like this morning. So let's see. If I went array prototype and I want some cool new method to put inside of prototypes, like say Nima is cared for. And here is a function that just returns, we'll do a return. I care. Now I'm gonna make some arrays, like let dogs. What did I call it? Say Nima is cared for? I heard you. Did you say it's not gonna work? Dude, you coming to my house? You coming to my house? So there we go. Did you, huh? Oh, we'll show console.log. The browser console automatically prints the return, so yeah. I mean, that's pretty funny. Right? And I imagine that maybe you can think of useful things to do with this. Right? Because from now on, every array is going to have this property. Right? Every array. But you might make useful functions for yourself. Okay? You might make useful functions. So, since we started the lecture late, I'm going to show you like one more thing before we take a break. For example, there's this thing called a notification that's built into your browser. And you can make new notifications, like new notification, saw dude. And like often, I have to do it from HTTPS. That's annoying. Okay, here's what we're going to do. We're going to go to compass.com. Not compass, web.compass.lighthouselabs.ca. And in here, I'm going to make a new notification. says saw dude. Did it pop up? Did you see it? Man, okay. So I don't know why it's not working right now, but what this should do is right across from here, you know when little notifications pop up, right? It's supposed to do that. My connection is not fully secure. Oh, oh no. So really what I'm trying to say is that like you can edit maybe a notification prototype to make notifications have special things. Like make it so that you can click on a notification to do something funky or something like that. We might explore that when we come back from the break. But have I convinced you that this is pretty interesting? I mean, that's pretty neat. Yeah, you get control over all this stuff, right? You have the power. Are there any questions? No questions from Calgary? Oh, cat. Oh, Pauline had a message here about soft kitten ball of fur. You deleted it. Okay, well, we're gonna take a let's take a 10-minute break. At 10:15, we'll get back, and I'm gonna show you some interesting class stuff, and then you're done. So, crew? Oh, I don't have to do anything over here. This is set. Okay. Hey everyone. Can I get confirmation that that Calgary is on the line? Gideon says, "Please don't stop." Oh, Braden's typing. Oh, is typing. Oh, Braden. Oh, they're racing. We are good. Okay. So I think I have decided I'm gonna start like a Twitch stream. It'll be like an educational Twitch stream. Like half the time will be coding tutorials, and then the rest of the time is me like badly playing Flash games, or like other video games. Yeah, I think it's a good idea. Wait, Davey, can I get funding for that? Can I get like a Twitch stream funding? Approved. There you go. I also I have like Sennheiser headphones to like look like a real gamer. It's funny because like the last game that I really played all the way through was Portal 2. Yeah, and before that would have been like Red Dead 1. So and Half-Life 2. Does anybody else like regularly Google Half-Life 3 just in case it got released and it just didn't get announced? Yeah, just look at that. Developer, Valve Corporation, right? Platform, Microsoft Windows. I mean, I doubt it. I think platform at this point is gonna be like a mobile game. Yeah. So let's just hop. Yeah. Don't you guys have phones? Yeah. Cool. So so when we left off, like I'd shown you kind of the difference between classes and function constructors was really just in the fact that like if I want to attach something to the prototype with a function constructor, I'm gonna have to do it this way. Where with a class, I can just write it inside, right? Just nicer syntax. I get to have everything within these curly braces as opposed to having everything written like this, right? So we're gonna play a little bit with anything else I want to say in here? I mean a little bit with some metaphors before we continue. OOP or object-oriented programming that you're exploring. I mean you've really already started touching, but you're really gonna explore next week. Is all about having a blueprint for a thing, so you don't have to repeat yourself. Right? And anytime you want to make something of that type, you can say, hey, use this blueprint. Now, the way that works in JavaScript and the way that works in Ruby, as you're going to see, is slightly different, right, when you explore it next week, but the concepts are pretty much there. And there's also the idea that given a set of blueprints, right, we can expand those blueprints to add more things. Right? So I might have blueprints for a building. Right? A blueprint for a building might have a roof and a frame and foundation, electrical, property taxes, walls, things that a building has. And then here's a house, which is a specific type of building. So a house takes everything that the building has, right? But it extends it with, okay, a house has its own front door, a backyard, a garage, a closet, maybe a dog next door. And then I can make instances of a house. I could say, okay, here's Nima's house, here's Kristen's house, and here's Tim's house. Right? Where Nima's house might have 3 glasses of water, a huge fridge, and also like heating for the water. Kristen's house has just nothing, and then Tim's house has 3 dogs. Right? They all still have everything they've inherited from the house blueprint, and everything that the house blueprint inherits from the building blueprint. Right? This is the idea behind OOP, is that I can create this stuff. And now, this line down here, Nima's house gets flooded. Basically, each of these houses is a unique instance. It's a unique object, right? It shares traits that it's inherited, right? But it's unique. So I can have Nima's house flood, and Kristen's house and Tim's house are totally fine, right? Connecting this to the code that you are writing, right? I showed you that you're using function constructors for things like when you're making new WebSocket connections, right? Remember how I said that you can have many WebSocket connections, right? You can have one of those WebSocket connections fail and the other ones are still fine because they're all independent. And this is a thing that's crucial to the idea of OOP, is just being able to think in that way. Now, prototypes and objects are, I'm just going to scroll down a little bit, but prototypes in JavaScript are like a loose version of object-oriented programming that you're going to see in on Monday, or really over the weekend. There's not much that I can say right now, but what you're going to see is that OOP in Ruby is going to be much more strict. Whereas here I can like loosely go around and I did this thing where I edited the I guess I hit it, where I edited the array prototype. Wait, what? Okay, for some reason it just said I care at the top of the screen and it was weird. Yeah. You know, I can do this stuff with JavaScript, but the Ruby, you're gonna see it's not as easy. Right. Now, I've put some examples in the notes that I want you to take a look at, but basically, this whole thing that I just did with buildings and houses, I want you to think about that in like abstract terms and come up with as many examples for yourself as you're working through this. For example, I might have a mammal type, and I've written this in like pseudocode. There's a mammal type that has DNA, eyes, and fur, and then there's cat type and dog type, and both of them say like, oh, I am a mammal type. So they don't just have the things that a cat type says it should have, it also has the things that a mammal type should have. I could say, okay, here's Spot, that's a new dog type, and Felix is a new cat type. I really want to stress, what I've written here, pseudocode. This isn't real code. Okay, but we're going to look at how we can essentially do this in JavaScript. And then down here there's some little example arenas. Now, in JavaScript, I can make classes. And we've seen class artist, I can give it a constructor, and we've also learned about the fact that I can give particular classes methods. Right? So artist, maybe this.genre by default is blank. It's got a say tagline that will say whatever this.tagline is. Right? Here I haven't set this.tagline. I've just written a method that does some stuff. And I'm not using it yet. I could go ahead and go, okay, here's Kid Cudi, new artist, and I could edit Kid Cudi's genre to good music. So let me just actually run this code. Here's an artist. Here's Kid Cudi, and I check inside of Kid Cudi and I see that genre is blank, and the type of this object is artist. And it said, genre should be blank. I just wanted to see what would happen if you do type of. It gives you object. And now the next thing that I could do is maybe go kidcudi.genre is good music. And now if I check inside of Kid Cudi, like, genre is good music. If I look at proto, there's this say tagline method. If I run that method, I don't get anything at the moment because that method is asking to console log this.tagline, which doesn't exist. But if I went ahead and I said, okay, like Kid Cudi.tagline, I don't actually listen to Kid Cudi. Yeah. Here's Kid Cudi.say tagline. I don't actually listen to Kid Cudi. Now, you've seen this syntax before. Class rock artist extends artist. I've got a class that extends another class. And what I've done in this class here, for the constructor is I'm calling super, I'm calling this dot genre equals rock, and I'm going this dot best ballad equals blank. Now remember, this is going to be a reference to the object that I'm creating. I'm going to run this code, and then we're going to explore what this actually does. So here's the class rock artist. And I'm going to do something like, okay, well, Zeppelin, new rock artist. If I check into Zeppelin, see the Zeppelin has genre rock best ballad. The proto is pointing to artist because a rock artist extends artist. And if I look into artist, then I can hop into the proto that goes to object. So rock artist is going to have genre now set to rock. Genre is set to rock. And best ballad is set to blank. There is still a say tagline somewhere, isn't there? Where is it? Is there? Let's see. Zeppelin dot say tagline. But where does it live? Where does it live? That's a real question. Where does say tagline live? Proto. Oh my god, I lost myself. This isn't part of the lecture. I just had a question for myself all of a sudden. Oh, there we go. Say tagline. Okay. Whew. It like sneaks up, and you have to go find it. But the thing is here, if I go Zeppelin.say tagline, I would get undefined unless I set Zeppelin's tagline to something. And Zeppelin songs, they tend to just kind of go like, ah, and then often mama at the end. So, Queen? Yeah, I guess. Oh yeah, ooh. Zeppelin.say tagline now goes wow. Now, something that you might have noticed is that I went super in here in the constructor. If I didn't say super in the constructor, I would end up with a big ol' error. Let's check it out. Here is artist. Here is rock artist, and I'm taking out the super. And I try to make a new artist. Well, let's see. I try to make a new rock artist, and I get a reference error. What does the error say? I must call super props before I can access this, or returning from my constructor. Okay, I must call super props. Not super props. I must call super. And you might have noticed when you're doing your React stuff, you go super props every time. Super props, right? Every time. Because the thing is, your React components, they're not just classes. They're classes that extend from component. From React.component. So if you're going to be overhauling the constructor, you need to call super. Here's an example of one that doesn't overhaul the constructor. Hip hop artist. I'm just going to remove this, and I'm going to go say tagline. And I'm going to override the other tagline. And this one's going to console.log. You know who it is? And now if I was to try and make a new hip-hop artist like Nima, my fledgling hip-hop career, this is fine, because I didn't touch the constructor. If I had touched the constructor, I would need to call super. So here's another example of hip-hop artist, where in this case I am calling super inside a constructor. I'm setting the genre to hip-hop. And then I've also made a boolean this dot is Kanye, which is going to be true or false depending on whether the name of the artist is Kanye West. So here's my hip hop artist. I'm just going to need to restart here the artist and hip hop artist. And what happens now is I can make new artists with a particular name. So I can make Nikki, and if I was to check inside of Nikki, is Kanye is false because that's what I set it to. And if I made Kanye, Kanye.is Kanye is true. I could go ahead and, oh, this was the example where I tried to do without super in the constructor. So this would break. Whoops, sorry about that. If I tried to go, oh, Mozart equals new classical without having super in here. Right. Do you know what super is? So super is a reference. It's a reference to like the parents constructor. So if I went I've just console logged whatever the super function is. What did I do? Super keyword expected here. Oh, am I not allowed to do that? I've never actually done it before. Does that kill it? Huh, didn't know. Well, super is going to be a reference to the parents constructor. Right? So this would be a reference to the artist constructor. Yeah, it's a good question. If I console log calling super, and oh, whoops, I had not removed the other one. And if I go, let's make a new hip hop artist 1, then it returns. So I guess console logging calling super returns the object itself, because I think what happens is super returns the object that will be returned anyways, and then it's been edited with genre and is Kanye, because it's a reference to an object, so that object would have been edited. Right. This is where things get, I think, a little abstract, and again, I really want to stress that it's not something you need to understand, even for the assignments. Okay. And then here I was just showing, again, the same as when I did array.prototype and set things, like array.prototype dot say you care about me. I can do that with artist, right? So artist, I could go into artist and say artist prototype tagline might be I am an artist. And then if you go Kanye.say tagline, since Kanye does not have a specific tagline inside of hip hop artist, it would hop into artist and go try to find, okay, well, does artist have a tagline? And I've just set the tagline right here. I've said artists, all artists that inherit, the artist prototype, they should have the tagline, I am an artist. However, Zeppelin, I gave Zeppelin the tagline, wah, specifically. So Zeppelin's going to have wah as the tagline. Just showing that, like, you can edit things at the prototype level. You can edit things at the prototype level. They will be inherited until somebody decides that they don't want to inherit it. And, I mean, that's prototypes. That's that. Yes. Well, if you wanted to prevent certain elements to be passed down, what you could do is in here, right, then set that thing to null or something. You can that's the purpose of having the constructor here for something specific that extends, is that you can overwrite those things. Right? So you can overwrite specific properties that are coming through. So an artist, for example, gives the genre blank, but in my constructor for hip hop artist, I'm setting the genre to hip hop. So I've prevented that blank coming through, right? Same with like if I had artist has say tagline, I can overwrite that in here and set my own say tagline for hip hop artist. Right? I'm overwriting it. If I didn't put it, then when you go dot say tagline on a hip hop artist, it would then go to the artist class. Right? But here I'm overwriting it. Yes. If you wanted to remove it, I think what you might be able to, yeah, like you could maybe say null. You might even be able to do like delete. I mean, we could try that. Here's artist that has this dot genre and say tagline, and I'm gonna make hip hop artist, and maybe I don't want. You know what? I'm gonna call this no genre artist, extends artist, which should still have say tagline but no genre. I think I can do this. Any artists with no genre, I guess. What's that? Andy Warhol? Yeah. Yeah. New no genre artist. And now what I'm seeing inside of Andy Warhol here is that there's no genre. Right? So I've straight up deleted this dot genre. Right? And you might even be able to do that with methods. So say I did I actually don't know, so we're gonna just find out. No say tagline artist. Maybe I can do delete this dot say tagline. I'm actually not sure. Let no tag. And then I explore this, and if I try to go no tag dot say tagline, no, I guess that doesn't work. It didn't throw an error is the thing. Right? And I guess it would be somewhere hidden inside of the proto. Yeah. Proto say tagline. Right? So I haven't been able to delete that. I don't know how I would actually do that. Mhm. Yeah, so that's what I'm doing here is delete this dot say tagline. Yeah, so if I did the round brackets, that would be invoking the function. Right? Here I'm just trying to delete the function, and I didn't succeed. So that's the tricky thing is like if I did this dot proto dot say tagline. Yeah, so see this proto dot say tagline like that. So I think it would be this dot proto dot proto. Yeah. The danger of this though, I think. Yeah, so so if I have an artist, let me make it like Kanye equal new artist, and I go Kanye dot tagline equals Saul. No, what does Kanye say? Huh? Yeah, I'm gonna let you finish. And then Kanye dot say tagline does this, and that's cool. I'm gonna let you finish. If I was to make one of these new artists, the no say tagline artist one, I'm curious to see what happens if I go Taylor dot say tagline. So Taylor now no longer has say tagline. It's not a function, and they might have interrupted Kanye. They actually did, yeah. Joe, the ultimate revenge. Yeah. So that's like dangerous. Yeah. Um and oh, I'm sorry, Calgary. I think I completely forgot to ask somebody. This is 100% on me. I didn't ask anybody to check the messages. So I didn't. Gamers rise up. Yeah, hit me up on Patreon. I'll let you know what my Patreon and my Twitch is next week. Yeah, Gay Ben will never deliver. What's that? I yeah, I'm gonna quit Lighthouse and become a full-time streamer. Archie, what do you think? Is that a good idea? Yeah. So, Davey just left. Sweet. So I think this is a good place to end it. Do we agree? Right. I want to say that your assignments, right? Like some of them are gonna align with some of the things that I've done, and some of them are gonna be different. Right. It's like week 6 at this point, so you won't necessarily be able to use exactly what I did to solve them. So just a heads up. I hope you have a okay understanding of what prototypes are now, and it really is the kind of thing that you'll learn as you tinker on. I'm hyped for you to finish Chatty, and I'm hyped for you to hop into Ruby next week. Have a good weekend, Calgary. See y'all.